right, so today we're going to finish up our notes on compound inequalities by introducing the union. So let's start with our definition of union. Here's our symbol for union. So when you see this U, union. That's a good one. So what we're going to do is we're going to take set A in union with set B to help us to write our definition of union. Here's how it goes. The union is the set that contains all elements of A and B common and unique. What they have in common and the things they don't have in common. This is a union. So here we have two sets. Set A contains the elements 2, 4, 6, and 8. Set B contains the elements 1, 2, 3, and 4. If I was asking you to find an intersection, you would say they intersect at 2 and 4, correct? Okay. However, this isn't an intersection. The intersection does say that they have to have common. They can have common. So, I'm sorry, the union. The union says that they can have common. So 2 and 4 is part of the union. But also it's everything that is unique. So what I'm going to do is I'm going to color code the unique in a different color here. And I'm just color coding. So what they have in common is part of the solution. And what they have that's unique is also part of the solution. So if I was asked to give the intersection, or I'm sorry, the union, A union with B, it would be the set, and we would start with the smallest value, which is 1. We would list their common 2. We would list their unique 3, the common 4, and then the unique 6 and 8. So this is what we call a union. It's anything from A or B. This is a union. If I asked you to create a Venn diagram, I'll put mine over here. They have overlap. Do you agree? Because they share the 2 and the 4. So we would put the 2 and the 4 inside. Oh, let me label that set A and set B. Okay. So that's their common. What's unique to A? 6 and 8. What's unique to B? 1 and 3. Now, how do I indicate the solution to the union of A and B? If you recall, when we did the intersection, we only highlighted their common because it was where they overlapped only. But with a union, it's common and unique. How am I going to highlight the solution to this? What? The whole thing. That's going to indicate the union. It's everything that's shaded is the solution. Okay. So let me just make sure you understand this. You don't have to write this down, but I just want to be really clear. So let's say I had set M and set N, and M had 10 and 11, and N had 14 and 22, and I asked you to do a Venn diagram of M and N. I want the union of M and N. Not MUN, but M union with N. Okay? How would I do that? Do they overlap? No, so I wouldn't put anything in the center, right? So this one would have, if this is N, that would be 10 and 11. And this is N, That would be 14 and 22. So, what would I shade? Just these. So that one doesn't have an overlap. And unions can look like that too. They don't have to have an overlap at all. Okay? So it can be the whole thing, or it can just be, if they don't have any overlap, that's okay. And you're going to see that right now when we graph this. You'll see kind of an indicator of what I'm doing right here. Okay? Don't go to sleep. All right. So bringing it back. The key word to denote a union is the word or. Or. Okay? Or means that the solution, the final solution, only has to be true for one of the inequalities. It doesn't have to be true for both. It's one or the other or both, but it only has to be true for one. Okay? So here we have a statement, x is less than or equal to 1, or x is greater than 3. So this says or, yes? So I cannot write this as a double inequality. So I'm going to make myself a little note. Cannot write as a double inequality. Just make yourself a note so that you don't forget that for later. Unions are never written as a double inequality. Okay? All right. So we have this statement here. I'm going to graph it over here. We got our boundary numbers, or our constraints, 1 and 3. And since the x is in front of each statement, of each inequality, can I use the arrow to indicate which direction? Yeah. So less than or equal to 1 would be going that direction, right? Or greater than 3 would be going that direction, using a non-inclusive versus an inclusive. And doesn't this look a lot like that? Can you see the gap? They don't have overlap, right? So if I have to write this in interval notation as I'm being asked to do, I can't write it as a single interval notation because there's a gap. So how we do that is we go from negative infinity to 1 inclusive and union with. So we use this for a gap. And you only ever use it if there's a gap in your graph. Okay? 3 to infinity. So if your graph has a gap, only if your graph has a gap, will you use the union symbol. Okay? All right. Any questions about that? Okay, I hope I'm making that clear. All right, so here we have problem A. Graph the solution, write it in interval notation. We see the word or, so that means we're looking for a union. It's good for one or the other. So we'll solve this first one. I'll solve it in blue. So I'm going to add 3, 5x is less than or equal to 13. I'll divide the 5. So we have x is less than or equal to 13/5, which is, for purposes of graphing, we're going to say 2.6, just so we know where to put it on the number line. Not so much that I want you to change it, because I don't. Leave it just like that. Okay? And then I'm going to graph, I'm going to do this one in purple. So we'll subtract 1. So x is greater than or equal to 4. So we've solved each inequality, and now we have to give our solution to the inequality. So we're going to graph it first to see what the solution is. So I'm going to graph. So I'll do, okay, so which one comes first, 13/5 or 4? 13/5, right, because it's 2.6, and 4 will be over there. Okay. So this says x is less than or equal to 13/5. Since the x is in the front, we'll use the arrow to help us. Right? So it's going that way, and we'll use a bracket. And then our last other one, x is greater than, so the arrow is going to the right with a bracket. Okay, so we see the gap. The gap is where the u goes. Okay, so that's the union. Because all of the answers in blue are the answers to A. All of the answers in purple are the answers to B. And it only has to be true for one or the other. So our interval notation, negative infinity to 13/5, bracket, union, 4 to infinity. And many times, when you're doing a union, your answer will have a gap in it, but not always. So don't think, okay, yeah, Mrs. Frame, I get this, and then stop paying attention. Because this isn't the only thing that you're going to see when it comes to unions. Okay? Sometimes they go in opposite directions and they do overlap. Sometimes they go in the same direction. So, these ones are opposite and they don't overlap, but it's not the only way. Let's take a look at B. Okay, so again we have an or. So we're talking about a union. It's only good for one or the other, or maybe it's good for both. We'll find out. So we'll start here by adding 5, adding 5. So negative 2x is less than 2. Divide by negative 2, so we're going to reverse the inequality. X is greater than negative 1. Right, because 2 divided by negative 2. We're going to divide the 6 off of that one, so x is greater than or equal to 0. So first I'm looking at this and I'm seeing something different from the last thing I saw. On the last one we had x is less than something and x is greater than something else. In this one, x is greater than both things. Do you see that? You're right, it is greater than 0, Anthony. But look, less than, greater than. See that? Here they're both greater than. So that means they're going off in the same direction. So when I make my number line, negative 1 here, 0 here. Right? All right, so greater than negative 1, we can use our arrow to indicate we're going to positive infinity. So all the stuff in blue is true for the first inequality. And then here we have this other one, greater than or equal to 0. So all the stuff in purple is true for the second one. And here we have overlap. Do you agree? So could I say, for example, that 1 is part of my solution? Well, let's look. Is 1 greater than negative 1? Is 1 greater than or equal to 0? So why is this not part of the solution? Isn't it? It's true for both. Does it matter if it says or? It doesn't. So the overlap is part of our solution. So how do you see a gap in my graph? Is there a gap? An opening where there's no color? Well, there's no color over here, but that's not a gap. Right? So our solution is from negative 1 all the way to infinity. Because the blue is only true for the blue. The purple is true for the purple. But the place where they overlap, purple and blue, is true for both. So when unions overlap going in the same direction, that's fine. But you start with the smallest part of your graph, and you end at the largest part of your graph. There's no gap in this graph. Like there is here. There's a gap right there. No color. Right? No gap. Color, more color. No gap. Okay? So they can look like that. Here's the last one. Now with this one, I didn't change the numbers. But I did change something. Do you see? Compare B to C. Which inequality did I change the direction? this one, right? On the other one, it was greater than. So we already know that this is x is greater than -1, correct? Oh, I'm going to change colors real quick. So we already solved that, so I'm not going to resolve it. X is greater than -1, but this one I will solve. Divide by 6, divide by 6. X is less than or equal to 0. Okay, so we're going to go graph those. And I think I meant to do this in like blue, so I'm going to circle that in blue. All right, so I'm going to put my two numbers on my number line, -1 and 0. And I'm going to use my colors. So x is greater than -1, so that one goes that way. And all of those answers are true for the first one. So that's part of our answer. And then this one says x is less than or equal to 0. Well, that goes, blue please, that goes that way. Forever and ever and ever and ever. So everything is in blue is true for this. So is there anything on my graph that's not colored? No. So my graph would look like this. Really fat. It's the whole number line. There's no gaps, and there's nothing on that number line that isn't true for this one or that one. Like I could pick -5. -5 is going to be true for the blue one or the purple one. Or says it has to be true for one. And says it has to be true for both. If this were an and, we'd only shade this center part where there's two colors. With an or, as long as there's one color, you're good. Okay, -5 is true for this, right? -5 is less than or equal to 0. That's true. But -5 is greater than -1. That's false. But it doesn't matter because it says or. It only has to be true for one. So -5 is part of the solution. What if I do -half? -half greater than -1, and that's a -half. Is that true? Yep. -half is less than or equal to 0. That's true. So I can still include that because it's true. And what if I pick 10? 10 is greater than -1? True. 10 is less than or equal to 0? Doesn't matter because it says or. So every single section of my graph has numbers that's true for at least one of my inequalities. So my answer, -infinity to infinity. So what I've just showed you there are the three different ways that you'll typically see a union. They'll graph in opposite directions without overlap. They'll have a gap. Or they'll graph in the same direction. Or they'll graph opposite directions, and in this situation, they will overlap. Okay? So that's the end of those notes. Okay? So do your summaries, and your assignment is 19 through 61 odd.